It's got one of the most terrifying names in all of medicine, the brain-eating amoeba. Yeah, it sounds like something straight out of a horror movie, but it is very, very real. And while the infection it causes is almost always fatal, this explainer, well, it's about an incredible, near-impossible story. The story of someone who actually survived.
Okay, let's just dive right into this. Imagine you're a parent. A doctor pulls you aside into a quiet room and delivers this exact news about your 12-year-old daughter, Callie Hardig. The diagnosis is something called Primary Amebic Meningoencephalitis, and her odds of survival are 1%. Just devastating.
But she did survive, and how she completely defied those odds is an incredible story of medical innovation, sheer resilience, and a frantic race against time. So how in the world did it happen? And what does her case teach us about this terrifyingly efficient little killer?
To really understand this disease, we have to start with the human side of it all. So let's look at the case of Callie Hardig to see how this insidious infection can kick off on what seems like a perfectly normal day.
It was just a typical summer day in Arkansas. 12-year-old Callie had been out swimming at a local water park. She comes home, tells her mom she has a really bad headache. Her family figured, maybe it's just dehydration or a bit too much sun. They couldn't have possibly imagined that a microscopic organism was already making its way toward her brain.
So, to understand what was actually happening inside Callie's body, we need to meet the microscopic villain at the heart of this entire story.
This thing is called Naegleria fowleri, and it's a thermophilic or heat-loving amoeba. It's a free-living organism, which basically just means it doesn't need a host to survive. It absolutely thrives in places like warm lakes, rivers, and hot springs, especially when the water temperatures get really high.
Now, this is a super critical point. The way this infection starts is incredibly specific. You can't get sick from swallowing contaminated water. The amoeba has to be forced high up into the nasal passages. From there, it has a direct, unguarded highway straight to the brain by following the olfactory nerve. Once it gets to the brain, the amoeba causes this absolutely devastating infection called Primary Amebic Meningoencephalitis, or PAM for short. And from that moment on, the clock starts ticking really, really fast. The initial symptoms are so deceptive. A headache, a fever, nausea. It can easily be mistaken for the flu or even something like bacterial meningitis. But as the amoeba destroys brain tissue, the brain begins to swell. And that leads to these severe neurological symptoms, like a stiff neck, confusion, hallucinations, and then, eventually, a coma. The terrifying speed of this disease is just relentless. As you can see from this timeline, after the symptoms start, most patients die within just 1 to 2 weeks. This makes getting an early diagnosis, which is so often missed because the initial symptoms are so generic, absolutely critical. And that speed, well, it leads to this staggering number. The fatality rate for PAM is over 97%. It is one of the deadliest infections known to science, which makes what happened to Callie Hardig feel like nothing short of a miracle.
So how is this tiny, single-celled organism so incredibly lethal? Well, recent research has started to reveal the microscopic toolkit it uses to cause such complete and utter devastation.
This is the central mystery for scientists, right? This amoeba normally just eats bacteria in lakes. So what switch gets flipped inside of it when it suddenly finds itself in the warm, nutrient-rich environment of the human brain?
Well, one of its primary weapons is a process with a fascinating name, trogocytosis. It comes from the Greek word trogo, which means to nibble, and that is literally what the amoeba does. It bites off and ingests little pieces of our brain cells. It's a brutal, contact-dependent method of killing that is just ruthlessly effective.
But it doesn't just nibble. Research shows it also deploys a kind of chemical arsenal. It ramps up the secretion of these things called proteases, which are enzymes that just dissolve tissue. And it has its own defenses, like something called NF-cystatin, which may act like a shield against our own defensive enzymes, and NF-hemerythrin, which could be a kind of scavenger that soaks up nitric oxide, one of the key weapons our immune cells use to kill invaders.
Okay, after all of that, you're probably wondering about the risk and what you can actually do. So let's put this terrifying disease into some perspective. So here's the crucial point. While PAM is incredibly deadly, it is also incredibly rare. For perspective, in the entire period leading up to 2015, there were only 138 known cases in the United States. And as you can see from that second bar, the number of survivors is just astonishingly low. Callie was one of them. And you can definitely reduce your risk. Since infection happens through the nose, holding your nose or using clips when you're swimming in warm, fresh water can help. Another risk, and this one is pretty surprising, comes from nasal rinsing. In some rare cases, people have been infected using devices like neti pots with regular tap water. The rule is simple. Only ever use distilled, sterile, or boiled and cooled water for nasal rinsing.
So how did Kali beat those odds? Well, it wasn't one single thing, but this combination of aggressive, innovative treatments. Her doctors used an experimental anti-parasitic drug called miltefosine. They put her in a medically induced coma and actually lowered her body temperature to 93 degrees to reduce that fatal brain swelling. And, critically, they diagnosed her, and they diagnosed her quickly.
Get this, at one point, the shipment of that experimental drug was actually lost in transit. But her medical team and her family, they just never gave up. This multi-pronged attack, fighting the amoeba directly while also managing the brain swelling, that's what gave her body the fighting chance it so desperately needed.
And here's the best part of the story. After everything she'd been through, one of the first things Callie did during her rehabilitation was get back in a pool. This quote just beautifully captures her spirit, doesn't it? She survived the unimaginable, and her passion for the water survived right along with her.
Her recovery was not easy at all. The infection left scarring on her brain. She had to relearn basic functions, how to walk, talk, and read. But after 55 days, she walked out of that hospital a living testament to medical possibility and incredible human resilience. And this brings us to a final, pretty unsettling thought. We know Naegleria fowleri loves warm water. So, as our climate changes, as we see hotter summers and warmer lakes spreading further north, could this rare but deadly threat start to become a more common one? It's a powerful reminder that the health of our planet is directly and sometimes terrifyingly linked to our own.